Hello, welcome to week 3, lecture 1, concept of load training 1. Let's start the lecture by reviewing what we covered in week 1 and week 2. In week 1, we covered the introduction of fitness variables, where health specific fitness variable and sports specific fitness variables were covered. Another concept of acute training variable, which is the first principle of training, was introduced, and this acute training variables was associated with each fitness variable. Week 2 started by introducing different principles of training. Apart from FITTVP, principle like gas principle, progressive overload principle, fitness fatigue paradigm were introduced, which helps to understand how to design a program using this principle. Apart from principles, the concept of periodization in sports training was introduced, which helps you to cover how to design the programs for different phases of your athletic training. Now, in week 3, we will be covering the concept of load training and load monitoring in sports training. Let's start by understanding what are the objectives of this lecture. We will start the lecture by recollecting what is training load. Then we will recall what are the different types of training load. Then we will understand how these different types of training load are interconnected with each other. And finally, we will end up the lectures by understanding why exactly is training load so important. The end outcome of lecture number 1 is you should be able to describe the importance of training load. It's only then you will realize why you should be using training loads into your sports training or physical training. And then you should be able to apply the concept of training load in designing an effective fitness program. Let's start by recalling training load. So what exactly is training load? It is a combination of frequency, intensity, and volume, where intensity and volume is considered as a work, that is the amount of work that you do with respect to your physical training or with respect to your sports training. And frequency, as described earlier in acute training variable, is number of training sessions per week. It is also called as density. Now, when we say about athletic training or sports training, frequency isn't a term that is more useful. Rather than the term density can be used, which is defined as the frequency at which an athlete performs series of repetition of work per unit time. We have to consider density rather than frequency when we speak about training load for an athlete, because an athlete in a given day trains multiple different parameters. Let's take an example. This is an example of an athlete on the training routine on Monday, where in EM, that in the morning session, he has one sports training session where he practices his sports skills or tactics, and then followed by a fitness training session. And then in the evening, he has another sports training session. So total duration is around 3 plus 2 plus 2, 7 hours. So on Monday, the athlete trains for 7 hours. So in such scenarios, if you use the term frequency, it doesn't describe the athlete's overall work that he has done. For that reason, we should be using densities, and there are two types of density. To start with, the relative density, which is defined as the percent of work done by an athlete compared to the total work within the training session. And it is calculated by formula absolute volume divided by relative volume multiplied by 100. Now let's understand this with the current example. The total work that an athlete has to do, it's been prescribed on Monday, is 7 hours. So out of 7 hours, let's say the athlete has done 5.5 hours. So you use the formula to calculate the relative density, which comes to be around 78.5%. So on Monday, this athlete has a relative density, that is the work done, is 78.5%. But it doesn't give a complete picture. During this 7 hours period, we are not considering the rest interval. This is where another type of density is useful, absolute density, which is the percent of effective work athlete performs. In this type of density, we exclude the rest interval. It is calculated by formula absolute volume minus volume of rest interval divided by absolute volume multiplied by 100. Now let's calculate for the given scenario. Out of 7 hours, the athlete completes 5.5 hours. But among the 5.5 hours, he has a total rest interval of 1, which includes an active rest or passive rest. So in total, then absolute density on Monday comes to be about 81%. Now you can see that density for a given day, for a given week, and then for a given month helps a coach or a practitioner to understand what is the quantity of work, the quantity of work that an athlete has performed in compared to what has been prescribed. And it's very clear that absolute density is much more useful in compared to relative density. So in the given example, on Monday, an athlete's absolute density is 81%. So whatever work has been given, he is able to perform 81% of the entire work given to him on Monday. Let's recall what are the different types of training load. There are 3 types of training load: a stimulating load, a detraining load, and a retaining load. A stimulating load is a training load which the athlete is not used to. It is a training load which is much more higher in compare to the previous session or a previous week. On the other hand, the detraining load is you give the training load which is much more less in the athlete's capacity, or it is much more less in compared to the previous session or previous week. And finally, the retaining load is giving a training load which the athlete is familiar with, or giving a training load which is same as that of the previous session or previous week. Let's see how these different types of training load are interconnected with each other. Let's say you give a training load for a stimulation load for a given week. And if you do not give another stimulation week or stimulation load for a given workout session or workout week, what happens is this stimulation load becomes the retaining load. And if you continue in a similar manner, that is, you do not give any other stimulation load, this retaining week will become a detraining load. So you may start a workout routine by giving a stimulation, but if you fail to apply a new stimulation, or if you fail to apply a stimulation which is much more higher, real challenging the athlete's capacity, that stimulation load, the recovery that has been achieved, the new baseline that has been achieved, as the time goes away, it will finally become a detraining load, and the new baseline that is achieved in the week 1 would ultimately diminish, and your new baseline would go down below the baseline number 0. That's the reason it's very important that you choose the load in such a way that you do not follow the stimulation load to become a retaining load, and to worst case scenario to become a detraining load. Let's understand this with an example. This is a 1-month workout to improve the power fitness, where the frequency is 2 days per week, entire month, and the progression here has been described where the stimulation is given every week. Let's change the scenario. I give a stimulation load in week 1, where the stimulation is given by increasing the box height, and when I give stimulation, the body would follow a gas principle where there will be a resisting phase, then giving enough amount of time for recovery, the body will overcome and get a new baseline and have an supercompensation phase. That's what will happen in week 1. Let's say in week 2, you are not giving any kind of stimulation. It's not applicable. You choose not to give any kind of stimulation. So using the interrelationship between the types of training load, in week 2, this stimulation load of week 1 will now become a retaining load. Now, when there is a retaining load, it means you are not given an opportunity to have a recovery phase, to have a resistance phase, and thereby there won't be any supercompensation phase. If you continue doing same in week 3, the same retaining load will now become a detraining load. So whatever adaptation you have achieved through the first week training to improve your power, by the end of the month, by the end of the 3rd week, you would able to lose all that adaptation just because you have not selected an appropriate stimulation load. Now, in order to get a stimulation or in order to improve your fitness level, what you need to give? You need to give a progression, in this case, progression in terms of variation, and that would start a new cycle of supercompensation to achieve. Why do you really need to know or understand and apply training load? Let's say you do not consider the load. You miss using the training load concept. In this case, you are not sure whether for a given workout session or for a given week, you are using a stimulation load or it is a detraining load or it is a retaining load. So what would happen when you are not aware whether you are using a stimulation load or retaining load? Recollect the gas principle. Whenever you give in absence of stimulation load, there won't be any resistance phase because you have not given an opportunity to challenge your system so that the performance drops, the recovery should start, the adaptation should start, which is actually the resistance phase. So in absence of resistance phase, you will never get the supercompensation phase. In absence of supercompensation phase, you will never get the new baseline. And ultimately, all the training that you are doing, you are trying to get new fitness baseline. So that's the reason monitoring, knowing, describing and applying the concept of training load is very important. Otherwise, you would have an understanding that you are training very regularly, but because you are not used the concept of training load, because you have not monitored the training load, and because you have not selected a training load optimally, you would end up having a same baseline in the worst case scenario, getting a baseline below the baseline number 0. So in summary, using the concept of density, not a frequency, will give you a more meaningful information about your athlete's training on per day basis, per week basis and thereby per month basis. Giving stimulation load at a correct interval and sequencing them between the stimulation load and retaining load correctly is very crucial to get a new baseline. Thank you.